Welcome to the FarmBits podcast.
FarmBits is proudly produced by the Nebraska Digital Agriculture team and hosted by the students at the University of Nebraska.
The FarmBits podcast comes to each week to discuss the trends, the realities, and the value of digital agriculture.
Through interviews with experts, producers, and innovators from across the agricultural industry, we hope that you step away from each episode with a new practical knowledge of digital agriculture technology. Hello, FarmBits followers, and welcome to another episode of the FarmBits podcast. I'm Katie Bathke.
And I'm Natasha, and we are glad to have you with us as we begin diving into the topic of digital agriculture tools in integrated pest management.
Joining us today, we have Fernando, who will speak more about his research and experiences in pest management.
Well, I'm an agronomist. I graduated at Federal Institute of Triângulo Mineiro in Brazil. And as an undergrad student, I had the opportunity of going to the US, to University of California in Davis, where I spent 1 year as an undergrad student and researcher. And over there, I started working with Dr. Kristen Nansen at the Department of Entomology. And basically, it's where I started learning about this science and about how to use remote sensing and all these digital tools in entomology. Then I came back to Brazil, graduated, and started my master's at University of Sao Paulo, where I also did my PhD in entomology and MBA in agribusiness. And ever since this last 10 years, I have been working with integrated pest management, and most of it with remote sensing to monitor pests in the field. So today I'm a professor at FAAGRO. It's an agribusiness university here. And I'm also a postdoc researcher at University of Sao Paulo. And now I'm working with radar technology to monitor pests. A little bit more advanced and hard to deal with, but we are getting there.
Yes. Awesome. That's a great way to segue. If you could give us a little bit of a brief description about your research you did with remote sensing and pest management.
Yes, sure. So basically, I've been working with optical remote sensing. I have been trying to read the plants, how they reflect light, and based on how they reflect light, we can tell if there's a problem with this plant. We work with controlled situations here and environments, so we know that the problem is pests. So we work with different species and different densities, different pest populations, and based on how the plants reflect the energy, we can say if something's going on with this plant and try to predict what's going to happen in the field if this plant is having an attack of this species.
That's great. And your research is conducted in São Paulo, or there is another places in the States that you conducted that?
No, I have been doing my research here at São Paulo State. Most of what we've been doing is in controlled conditions, so lab conditions or greenhouse, but we also did some field work over the last 2 or 3 years in big soybean fields, but they are located here in São Paulo State, just to make it easy to travel around and collect all the data and collect plants and insects and all this kind of stuff.
Yeah. So before we dive into the specific pest portion of this interview, can you talk to us about the intersection of integrated pest management and digital agriculture and what kind of makes this merger of these two topics really important?
Sure. I'm really happy to talk about it. I get excited talking about it because I've always studied integrated pest management, and I get excited about all these concepts and all this knowledge that we have been learning for the last 4 or 5 decades. But now digital agriculture is a reality, and we need to look at it and see how can we merge IPM and digital agriculture. So we have been talking a lot about precision pest management. So we respect, we understand all the bases of IPM. We are not giving up on anything from IPM. Actually, we want to use all the tools, all the bases, all the strategies from IPM, but we need to adapt these concepts or these tools to our today agriculture, the digital agriculture. So one of the bases of IPM is to monitor the fields and to know how much we have of each pest species, when they get there, where they are in the field, to choose the best tools to manage them. I see here a great opportunity to use digital tools, basically to monitor the fields, know where and when the pest arrives in the field and spreads over the field, and then we can use other traditional tools or digital tools to manage these populations, especially in hotspots. That I have been talking about that, and not just me, but whoever works with this technology always talks about using these tools to manage pests in the hotspots, not to spray the whole field if you know where and when the population is.
And Fernando, can you tell us what type of pests are you able to monitor with this technology that you're using, and which crop you are testing with as well?
Yes, sure. I am. People ask this to me all the time, and always I say that one thing we know for sure is that we still don't have any tools developed or available to monitor all kinds of pests in any crop. It is really specific. We have the tools, but we still need to use them in proper ways. So I have been working with soybean pests, and basically with multispectral and hyperspectral sensors. And the best results we achieved so far were when we studied caterpillars and also whiteflies. So I can talk to you a little more about that. That's what I know. So I have been reading that we can monitor other kinds of pests in other kinds of crops, but my small contribution to this field is with soybean.
Okay. And then with that, can you tell us a little bit more about the type of technologies growers can use to monitor and manage important pests?
Yes, sure. So we have many optical sensors available, and they are being used, especially when we attach them to drones or when we have them attached to satellites. And we have been using them for other reasons, like for nutrients management or water management. I have seen many episodes in this podcast regarding nutrient and water. And we can use this same tools, but we still need to understand a little more of the details. Like when we talk about multispectral sensors, we can say that the grower is gonna know that there is something wrong in the field, but what's going on is still a little hard to say. So based on that, we say that hyperspectral sensors can help us telling what's going on in the field and where it is happening and when it is happening to monitor the best way. Another digital tool that has been used so far in very big fields are the automated traps. So they are not just a simple advance, but it is not a groundbreaking technology. We have the traps that have been used for a long time with pheromones, and we have cameras on them now. And when the insect gets there, we have pictures, or we have the data sending information to the growers every day, like you have some moths getting in your field, you have to pay attention that in a few days you're going to have caterpillars and you need to manage them. So these are just some examples of digital tools that can help the growers a lot.
Oh, nice. And well, since you already mentioned some technologies that farmers can use, and you already have mentioned some benefits, the use of these tools, But you have another benefit that you can say when farmers use the digital tool, because we know the cost is not low to use those
Mhm.
techniques. So what would be the most benefit for farmers to have this?
Well, we like to think that spraying less pesticide is going to be really good for the environment and for the growers' income. Also, using this kind of tools, growers might be able to monitor the populations when they are still getting to density that cause problems to them. Like we don't say that they should manage before economic thresholds or injury thresholds, but these digital tools can give them some advice, like in a few days you're going to have a big problem, so you can be aware and you can choose wisely which option, which tool you can use. Like today, most of what is done is when when we see pest outbreaks in the field, growers are going to spray chemical pesticides all over the field. But we have many more options like biological tools that can be used if you know that the population is still in lower levels, is still getting to injury thresholds. So we can think about many other benefits, but mostly I say that reduction in pesticide use is the best one.
And I believe even in time, right? Because to scout the field, it takes time as well.
Sure. Like we say that grain fields here in Brazil, like maize or soybean or cotton fields, we have really large fields, thousands and thousands of acres, and it is really challenging to monitor these fields with not with traditional tools, like with the eyes, with people walking all over the field. And basically what we see is that many growers don't do monitoring. They just spray on a calendar basis. And if you go back to the basis of IPM, it's completely wrong. Like you don't need to manage something that you don't know if it is there or how many of them or where they are. So using digital tools, we will probably know in some years where the pest is, how many of them there are, when they get to the field, and then choose wisely the best tools to manage them.
Yeah. So you've talked quite a bit about these technologies and the importance of growers using them. Can you now talk to us a little bit about the types of data that these tools are collecting and how that can become useful for the grower?
Yes, sure. I say that in the research that we do, it is nice to have as many data as possible. But for growers, they need simple answers. They need simple information. Like in that field, you have a problem, and with this species or that species, or with caterpillars or with stink bugs. Using the automated traps that we talked before, they can know basically which species of moth or caterpillar is there. But based on optical sensors, we still cannot say for sure which species is there and what kind of problem they are going to have. So we still need to develop more the analysis tools and how to deliver information to the growers, because talking to growers and going to the field, we say that what they want for sure is like a message in the cell phone saying you have a problem in the field, go there and do something. They don't want to look at beautiful maps with all kinds of colors and densities, and they want to know what's going on and how to manage this. So I think this is where we need to get.
So can you tell us if it's possible to use the remote sensing to to monitor this pest and how it can be done?
Yes, so it is possible. We say that it is possible based on science, based on what we did in lab conditions and greenhouse conditions. And actually, we went a little farther because we know that looking at talking to growers and looking at the weather, they always say that during the raining season here in Brazil, if there are some days that are dry, the whitefly populations usually grows a lot. So we said, well, we need to look at that. So we had different soybean plants with different water densities. So we saw that plants that didn't have as much water as they should have, they were more preferable by whitefly. And also we did some remote sensing with this. So basically what the answers that we got is that, yes, we can say that one plant is infested by whitefly. And also we could say that some plants are more preferable to whiteflies based on their reflectance that is a result of their water deficiency. So we can think about other possibilities regarding this matter, like nutrient deficiency or water deficiency. It is a way of going still a little more farther. Like you can say that these plants are likely to be preferred by the pest. So it's one step ahead.
Yeah. And then could you, I don't know if you have an example of the use of UAV in pest management that you could share with us, like one that you seem to be really beneficial?
Yes, sure. So UAVs are vehicles, right? They are flying robots, and the technology that we see there is basically is what we attach to them. We can attach sensors and monitor the field. We can attach natural enemy releasers and release natural enemies all over the field. We can attach a sprayer and spray a chemical pesticide in the hotspots. Here in Brazil, we saw a huge advancement in the use of biological control, especially in sugarcane fields, in soybean fields, and it is 100% based on the use of drones to release natural enemies. Before the drones, we needed men walking all over the field, releasing some plastic cups with wasps or with mites. And now we see drones flying all over the field, releasing these natural enemies with a really high efficiency and much cheaper and much faster than a man can do.
Yeah. I think that's really interesting that you talk about biological controls. My previous research was in biological control. So I really like that drones are being used in that. I like that.
Yes, they are. They are.
And going back to one of your research that we found, so you worked with, as you mentioned, hyperspectral proximal imaging. And so you test this technology with 4 major pests in Brazil, right? So can you tell us a little bit about those pests and also what you could find with those with this research?
Yes, sure. So before we did that research, I dived in the literature, and I thought that sucking insects would be better for me to have interest. So I decided to work with 2 stink bugs and 2 caterpillars, 2 chewing insects. And I was really happy to see that at the end of the research, our best results were achieved with the caterpillars. And then we started to think about this. And so what we did for 10 days, we had different numbers of insects per plant in a cage in the greenhouse. And at day 0, day 5, and day 10, we took some samples and we checked how these plants were reflecting the energy based on a hyperspectral sensor. And we saw that even like after only 5 days of the insect feeding on the plant, and in population densities below the injury levels, we could say that this plant was being attacked based on how the plant was reflecting light. So if we think about how to use this in the field, maybe in the future, as I said before, we can tell the grower that there is a problem going on, and this problem is increasing, and they should be aware, and not just to manage a problem after it is a big problem. And regarding the stink bugs, even at big densities, at 10 days of the pest feeding on the plant, we didn't have enough change in the way the plant was reflecting light. And then we started thinking about that, and it makes sense because the insects were feeding on the pods, and it would take a little longer for the plant to have a physiological change that could be seen by the sensor regarding how the leaf was reflecting the light. So in this research, we concluded that hyperspectral sensors can be used to monitor chewing insects, caterpillars, even at densities lower than injury thresholds for the soybean conditions here in Brazil.
Yes. And with your research and your experience, do you happen to have an example of, or know of any technology that could be used for insect resistant management?
Well, for field work, to my knowledge, I don't know any examples, but I know that in the lab, especially the use of molecular tools and digital tools, and merged with these molecular tools, the researchers are having huge advances, basically studying the genetic base and the molecular base of resistance.
That's awesome.
And as you mentioned before, so I think when we talk about remote sensing and digital tools for nutrition, for example, we can find more options and more information. But for pest management, I believe is more complicated because, for example, the pest it moves, so it's difficult to have a occurrence. I can say data for the pest management, not the occurrence, but for example, know that there is a problem in the field and to already know which insect it is, for example. So can you tell us a little bit about this challenge that the farmers face when to try to differentiate about biotic and abiotic issues using digital tools?
This is our most challenging thing here now in this research. I like to say that using multispectral sensors that are the ones that are available, that are cheap, that are easy to use, and we can find many different options. We are measuring like the fever. Like if a person has a health problem, has fever, okay, but what is the cause? What is going on there? So we need other tools. And regarding optical remote sensing, we say that hyperspectral sensors are these tools, are the tools that we can use to try to differentiate the stressors that are causing problems in the plant. Well, one thing is that plant pathogens or nutrient deficiency or water deficiency or even the pests, basically they change the plant structure and the way the plant does photosynthesis, and by that we say that the plant is reflecting more or less light. So we need to do a lot of research to try to see which wavelengths where in the spectral part of the light one insect is changing or one pathogen is changing, and we say that we are looking for reflectance patterns, like a signature from each kind of stressor. And so it is a huge work that should be done by many people in many different conditions. And if data are shared, we will probably have a faster advance. Like if you in the US know what we are doing here in Brazil or what people are doing in China, we will for sure advance much faster in this technology.
And I like this comparison between, for example, when we got fever, so we need to look more about what is the main reason for this. And it's the same in the field, because the digital tools can help us to know where the problem is. So we can go there and then look for the reason for this.
Yes, we say that here because some people, some growers or some crop consultants, they say, oh, this technology is not ready yet. And I say, well, if you don't have these digital tools, how would you monitor thousands of acres? You don't monitor thousands of acres. So if only you know that something is going on in this part of the field or that point or that point, you can tell someone to go there and look and see what's going on, right? You don't do like a blind monitoring. You go to specific points of the field and you just check what is going on there. It is one advance. We of course we want to get to a point where the drone or the satellite just collects all the data and tell us what's going on. We still didn't get there. Maybe in the next 10, 20, 30 years, we are gonna get there. I like to say that today we are a little closer than we were yesterday. We are not there yet.
Yes.
But we are a little closer than yesterday.
Yeah. So we're going to kind of shift this into more of some of our questions about grower adoption. So do you have growers who are interested in trying digital technologies for pest management in Brazil? And if so, what kind of tools have they been using?
Yes, there was a really, really nice research done by Embrapa, which is public research institution for agriculture here in Brazil, like USDA. And so they were asking growers, do you use any digital tool? And I think 70 or 80% of them were using. And which kind of tools? Well, they were using their cell phones, they were sending messages, they were getting quotes, they were talking to crop consultants, they were talking to their neighbors using digital tools. And okay, but this is what most of them were doing. And of course, some of them were using really advanced tools, like all kinds of sensors and knowing everything about their machines, how they are moving, how much fuel they are using, and all kind of stuff. Using maps, using yield maps, using soil maps, soil fertility maps, and mostly what where we see much of the advance is in nutrient management, and I would like to see some more advance in plant health, plant protection, like plant pathogens and weed management and insect management.
Yeah, I think as you just mentioned about the research that Embrapa did about the use of digital tools for farmers in Brazil, and they use more cell phone and like sharing the message with the neighborhoods. So I think this may be one of the reasons is because maybe the use of digital tools is still not accessible for every farmers, right? Because as you mentioned, there is a cost, and even some farmers doesn't know how it works as well. So in your opinion, do you think this type of technique can be accessible for every farmers in the future, and how it can happen in the future? You know, do you think, for example, if we have more work together with universities in Brazil, with farmers, maybe it could help farmers to learn more about how to use this technique.
Yes, sure. Well, I see some different ways we can get there. The first one is for us researchers and the industry to have simple tools. Like if you, like we were saying before, if you have a tool that sends a message to the grower, everyone now has a cell phone, everyone now has access to internet and now all kind of communication. So if we have simple tools, I'm saying digital tools. So all the research, all the groundbreaking technology is in the industry or is in the university, but the information is simple to the growers. And also one other way is if the growers work together, like in co-ops, like one big grower, it is really easy for the grower to buy a drone or to buy to have access to satellite data for his farm. But for a small grower, it is not accessible. But if 10 of them or 15 of them work together and buy a digital tool and buy a really advanced equipment, they can share this equipment and they can use the most of it. Also by service providers. If they don't want to buy the technology, if they don't want to buy the tool, the equipment, a company can buy it and sell the service to the growers, not just to sell the equipment. So we have different ways to take the digital agriculture to small growers as well. And this is where everyone wants to get.
Yeah. I love that perspective and kind of your thoughts on reaching more than just the larger growers in the digital ag community. I think that's really important. So we were kind of wondering, what are your biggest challenges you faced with your personal research and kind of how you overcame that?
Well, first of all, when we bought the equipment, we didn't know anything about it, so we needed to talk to other researchers and learn and study and read. So some of the challenges were technical. And well, if you do field work, if you are in a plant science major, if you are an agronomy major, you need to know that every time you think about field work, you need to think a lot about it. So over the last 3 seasons, many different situations happened. Like you ask the grower not to spray anything, and in the other day the grower is spraying pesticide, or you travel 1 or 2 hours to collect data and it's raining, and tomorrow you go again and it's raining again, and many kind of technical challenges. But it is also the best way to learn. Like if you go to the field, if you look at the plants, if you look at the insects, it is the best way to learn. You need to have all the reading, you need to have all the basic, but it is really important to have applied knowledge as well.
Yeah, and work like our area that we depend on the things that we cannot control. For example, weather is always a big challenge.
Yes. Yes.
So about the future of digital tools and advanced technology that farmers can use, what is your vision for this topic?
So I would really like to see an increase in the adoption of IPM based on the use of digital tools. This is what I would like to see. I never say that integrated pest management is going to be in the past. No, it is the basic. It is the basis of precision pest management. And what I would like to see in the future is all these ideas that we have been talking over the last minutes being applied, like a sensor that can tell the grower where the insect's getting in the field, how much it is spreading in the field, and you have like a drone that can move to this hotspot and spray a selective pesticide or release natural enemies and control this population just in the hotspot. This is my vision of pest management in agricultural and digital agriculture.
That is great.
Yeah. Is there anything we didn't talk about today that you might want to add or mention to share with our listeners?
Well, sure. I would like to say that I define myself as a bridge. Like I am an agronomist. I love studying plants and insects, but I'm really excited about the digital tools as well. And it is impossible for one to know everything about the digital tool, everything about pest management, everything about agriculture. But if you know all the bases and if you can communicate with these two worlds, like being a bridge, you're gonna be successful in this new agriculture.
That is true. So Fernando, we're going for our last question of our interview. So we have a tradition that we like to ask for a piece of advice. So what advice do you have for farmers that are facing challenge with pest management?
Well, don't give up on the research. Listen to what we are saying. Listen to what we are doing, and farmers have to know that we are playing for the same team. We want them to be successful. We want them to be profitable. We know that this is their life. This is what they do to raise their family, and so if they work with us, help us developing the tools and listen to us, and don't give up on research, I think we are gonna have a nice future for pest management.
Thank you very much to Fernando for taking time to join this episode on the FarmBits podcast. It's really exciting to know more about how farmers can utilize advanced techniques in integrated pest management practices. One of my favorite parts of this episode is when Fernando mentioned the use of UAV in biological control.
I would have to agree. I also really enjoyed his perspective on what advanced remote sensing techniques can do for the future of pest management and agriculture. I hope you enjoyed this episode, and we look forward to sharing another digital egg story with you next week on FarmBits.
Thank you for taking the time to join us today on the FarmBits podcast. If you enjoyed this episode, please subscribe to the podcast on Spotify, Apple Podcasts, YouTube, or whenever you listen to podcasts to be informed about the latest content each week.
We welcome your feedback, so if you have comments or questions for us, please reach out to us over email, on Twitter, or in the review section of your favorite podcast platform. Our contact information can be found in the show notes.
We would like to thank you, Nebraska Extension, for their support of this podcast and their commitment to providing high-quality informational material to members of the agricultural community in Nebraska and beyond.
The opinions expressed by the host and guest on this podcast are solely their own and do not reflect the views of Nebraska Extension or the University of Nebraska-Lincoln.
We look forward to you joining us next week for another episode of FarmBits.